Lesson 2.2, Dividing Fractions. In this lesson, you will write reciprocals of numbers and use models to divide fractions. Two numbers whose product is 1 are reciprocals. To write the reciprocal of a number, write the number as a fraction. Then invert the fraction. So the reciprocal of a fraction a over b is b over a, where a and b cannot equal 0. The meaning of the word invert: when you invert a glass, you turn it over. So when you invert a fraction, you make the numerator the denominator and the denominator the numerator. The product of a non-zero number and its reciprocal is 1. Product is multiply. If you multiply a over b times b over a, you will get 1. This is called the multiplicative inverse property. You'll learn more about this property in Chapter 7. In questions A, B, and C, we're given a number, asked to write it as a fraction. Sometimes they already are as a fraction. Write its reciprocal, and then check to see that the multiplicative inverse property holds when we multiply the fraction by its reciprocal and get 1. Question A is 3/5. 3/5 is already a fraction, so I will just rewrite it as 3/5. The reciprocal is when I invert it, so that means that the numerator becomes the denominator, and the denominator now becomes the numerator. So the reciprocal of 3/5 is 5/3. And if I multiply those across, 3/5 times 5/3, I would get 15 over 15, which equals 1. So the multiplicative inverse property worked. Question B, 9/5. Again, that one's already written as a fraction, so I will just recopy it, 9/5. The reciprocal, take the numerator, make it the denominator. Take the denominator, make it the numerator. I'm just basically flipping the fraction over. If I multiply those to check the multiplicative inverse property of this fraction, 9/5 times its reciprocal, I would get 45 over 45. Any number over itself is the same as 1 whole. Again, the property holds. And on C, the original number is 2. Written as a fraction would be 2 over 1. Now making its reciprocal, I would bring the numerator down to the denominator and take the denominator and put it as the numerator. So the reciprocal of 2 over 1 is 1 over 2, or 1/2. When I multiply the fraction times its reciprocal, 2 times 1 is 2, and 1 times 2 is 2. I get 2 over 2. Again, any number that's the same for both numerator and denominator is equal to 1. Key idea: dividing fractions. In words, to divide a number by a fraction, multiply the number by the reciprocal of the fraction. In numbers, that would look like this: 1/5 divided by 3/4 equals 1/5 times, so we're changing the division to a multiplication, times the reciprocal of the second number, 3/4, which means we put the numerator as the denominator as the numerator, so the reciprocal of 3/4 is 4/3, and that leaves us with 1/5 times 4/3. 1 times 4 is the numerator, 5 times 3 is the denominator, and then you could continue on from there. In algebra, a over b divided by c over d. Again, we keep the first fraction the same, a over b. We're changing the division sign to a multiplication sign. And then we are inverting, or putting the reciprocal of the second fraction. So c over d becomes d over c. And then multiplying numerators, a times d is the numerator, and b times c is the denominator, where b, c, and d cannot equal 0. So what is the process exactly? KCF. Keep it, change it, flip it. Keep the first fraction the same, change the division sign to multiplication, and then flip the second fraction over, finding the reciprocal. Example 2, dividing a fraction by a fraction. Let's try that. Keep it, change it, flip it, and see how we do. Keep it. I keep my first fraction. Change it. I change the division to multiplication. And I flip the second one. Keep it, change it, flip it, and now I can multiply. Before I do that, though, I see a common factor here of 3's. There's a 3 here that I can divide out, and if I divide 6 by 3, I would get a 2 there. So I might as well reduce that, simplify it now. 1 times 1 is 1, 2 times 2 is 4. So 1/6 divided by 2/3 equals 1/4. Example 3, dividing a whole number by a fraction. A piece of wood is 3 feet long. How many 3/4 foot pieces can you cut from the piece of wood? I'm going to try and solve this 2 different ways to show you 2 different ways to do this problem. The first way is by drawing a picture using a model. So I've drawn this piece of wood that is 3 feet long, and I've marked it off into each 1/4 of a foot. Those are the dashed lines. And now I'm asking myself, how many 3/4 foot pieces can I cut from this piece of wood? So I'm going to count 3/4. 1, 2, 3/4, that's 1 piece. 1, 2, 3/4, that's 2 pieces. 1, 2, 3/4, that's 3 pieces. And 1, 2, 3/4, that's 4 pieces. So by drawing the model, I can see that I could cut 4 3/4 foot pieces from this piece of wood. My answer would be 4 pieces. The other way is to do it algebraically. 3 foot long divided into 3/4 foot pieces. Keeping in mind my keep it, change it, flip it now, the 3 I will keep, change the division to multiplication, and flip my last fraction to 4/3 from 3/4, making the numerator now my denominator and my denominator now my numerator. And now I can multiply. 3 times 4 is my numerator, and 3 on the bottom, this is really the same as 3 over 1. 3 over 1 is the same as 3. I'm making it into a fraction so that I can see that clearly. And I can also see that I have a common factor of 3 here in the numerator and denominator, so dividing those both out by 3 would leave me with 1. Now I have 1 times 4 is 4, and 1 times 1 is 1. Any number over 1 is its own number when we simplify, so 4 over 1 is the same as 4. 4 pieces of wood again. Four pieces of 3/4 size. Example 4, dividing a fraction by a whole number. Find 4/5 divided by 2. Thinking of my keep it, change it, flip it, 4/5 stays the same. Changing the division to multiplication. And flipping the 2, I'm going to make that 2 into an improper fraction up here so that I can see what it looks like. And now when I flip it, it becomes 1/2. 2 and 2 over 1 are the same thing. I just wrote it as an improper fraction so that we could easily see that when it's flipped it becomes 1/2. Common factor of 2 here, so 2 divided by 2 is 1 and 4 divided by 2 is 2, and now I can multiply. 2 times 1 is 2 and 5 times 1 is 5. 4/5 divided by 2 is 2/5. Example 5, using order of operations. Evaluate 3/8 plus 5/6 divided by 5. Order of operations, thinking back, that is, please excuse my dear Aunt Sally. Parentheses, I don't see any parentheses. There are no exponents. Multiply and divide, I see a division. So that's where we'll start. I'm going to record the 3/8 just to make sure I don't forget that I have to do that part later. But this portion of the problem right here, 5/6 divided by 5, is what I'm going to work on first. And it's a division problem, which takes me back to keep it, change it, flip it. So keeping the 5/6, changing the division to multiplication, and flipping the 5. Remember that 5 as a whole number can be written as an improper fraction as 5 over 1. Those are the same. So when I flip it now, I can see that very easily becomes 1/5. And now I have a multiplication problem, which still comes before addition, so I'm going to multiply there and record the 3/8 again just so I don't forget that I have to do that. 5, I see, is a factor in both the numerator and denominator, so I'm going to divide those out right now to simplify. And I have 1 times 1 is 1, and 6 times 1 is 6. That leaves me with now the problem 3/8 plus 1/6. I see now that I need a common denominator. I could write multiples of 6 and 8 until I found one that matched, or I can use the other method where I use the denominator from the alternate fraction, which is what I'm going to do in this case. So 8 and 6. So my first fraction here I'm going to multiply by 6 over 6, which again is the same as 1. 6 over 6 is 1. It won't change the value, but it just changes the size of my fraction. So I have 3 times 6 and 8 times 6. And on the second fraction then I'm going to multiply by 8 over 8, which again will not change the value of my fraction, it just changes the size. And now I have 48 for my denominator on both fractions, so that clears up the need for the common denominator. My first fraction I have 3 times 6, which would be 18. And my second fraction I have 1 times 8, which would be 8. Now I can add those together because my denominators are the same. So my denominator stays as 48, and 18 plus 8 is 26. I see there that in my ones column I have an even number in the 6 and in the 8. That tells me from my divisibility rules that I should be able to divide both numerator and denominator by 2 to simplify. Again, dividing by 2 does not change the value of my fraction because I'm not really dividing by 2. I'm dividing by 2 over 2, which is 1. Taking a factor of 2 out of both of those, 26 divided by 2 is 13, and 48 divided by 2 is 24. And now I know it is as simplified as I can get because 13 is a prime number. So 3/8 plus 5, 6 divided by 5 equals 13/24.